Now let's try and name the isomers of C6H14. First we need to draw them. Try it yourself first. Pause the video and try to draw the isomers that have the formula C6H14. The best way to do it is systematically. Start with the longest possible chain and then add branches bit by bit. First you have a 6-carbon chain. This is hexane. Next, if you remove one carbon from the main chain and make it a branch, and you can put the branch here, that makes an isomer. Or you could put the branch here. These are two different molecules. Or you could put it here. Now, is this another isomer? If you look carefully and compare it with this one here, it's actually the same molecule just flipped around. So that's not an isomer. So we'll cross that one out. Now, we could take 2 carbons off the main chain and use them both as branches. So that's another isomer. Or we could attach both methyl groups to the same carbon, making a sort of cross shape. That would be another. And then another option would be if we took 2 carbons off the main chain again, but instead of attaching them as 2 separate methyls, could we put them on as one ethyl branch? Let's try that. Okay, it looks different, but let's find out if it really is. What's the longest possible chain on this molecule? Can you see it? It's 5 carbons long. And the methyl branch is on the 3rd carbon of those 5. Well, that means this molecule is actually the same as this isomer here. It's just that we've bent it around in a curve. Try drawing this out for yourself if it doesn't make sense immediately. Okay, so let's see if we can name these. The first is easy, that's hexane. But the next two are difficult. They both seem like they should be called methylpentane, but they're clearly different molecules, so we need a way of distinguishing between them. Can you think of a sensible way of dealing with this? Well, let's go back to the naming rules and see what the chemists came up with. You can see that number 3 on our list of rules is to number the chain consecutively, starting at the end nearest a multiple bond or substituent group. So we're going to number the carbons in the main chain. And then, rule number 4, you designate the location of each substituent according to the number of the carbon that it's attached to. So let's try this out. So let's look at the 2 methylpentanes first. The rule said to number the main chain consecutively, starting at the end nearest the substituent. So we'll number the carbons in the first one like this. And that means you can see that the methyl is attached to carbon number 2. So the way we name this is 2-methylpentane. And that tells you that the methyl branch, the methyl substituent, is attached to carbon number 2 of the main chain, which is pentane. Okay, in the second one, the substituent is right in the middle, so it doesn't matter which end we start from when we number the main chain. Either way, it's going to be on carbon number 3. So this isomer is called 3-methylpentane. What about these guys? Well, first of all, what's the longest chain in the molecule? You can count it up. There's 4 carbons, so the main chain is going to be called butane. And then it has 2 methyl substituents. And if we number the carbons, you can see that one methyl group is on carbon number 2 and one is on carbon number 3. So in the name, we need to indicate that there are 2 separate methyl branches. So we've got 2-methyl and 3-methyl. We could just write 2-methyl, 3-methylbutane, but that would be not particularly efficient. So it turns out that the rules have a way for us to deal with this. What we do is we use the prefix di to indicate that there are 2 of the same kind of group. So this molecule is based on butane. It has 2 methyl groups, so we say dimethyl, and the carbons that they're attached to are carbons 2 and 3. So the final name of this molecule is 2,3-dimethylbutane. Note the comma between the numbers. We always separate numbers using a comma, and we separate numbers and letters using a hyphen. Okay, for our last molecule here, again we number the main chain, it's butane, and this time we find that the 2 methyl groups are attached to the same carbon. So it's still dimethyl, but they're both attached to carbon number 2, so the name is 2,2-dimethylbutane.